The concept of something being long-lasting is a double-edged sword. On one hand, it'll be there forever, persistent, enduring, and sturdy. But on the other hand, it will be there forever. Such is the case for a persistent pollutant known as PCBs. PCBs are ubiquitously found around the world, in water systems, in soils, and of recent concern, building materials like window caulking, wall paints, resins, glues, etc. Now, school buildings built with PCB-ridden materials, as the building ages, PCBs will accumulate in the air. Recent studies have actually shown that indoor air concentrations are much higher than outdoor air. Now, this is especially problematic for people who spend 6+ hours a day in these buildings, like staff, students, and teachers. And now, if we try to imagine what it's like being a teenager, we all remember what it's like being a teen. Braces, drama, social awkwardness, and parents who just don't get it. It was hard enough trying to succeed during those years. But on top of that, add spending 6+ hours a day in a school building contaminated with PCBs, hindering your academic potential. Now, this is a concern as PCBs have been known to cause many long-term effects in humans, including hormone dysregulation, cancers, and brain dysfunction. And for school-age children whose brains are still being molded by learning, social interactions, and experiences, PCBs can really pose a threat to their normal brain development. But a question remains unanswered. Are PCBs getting to the brain tissue, or are they just circulating the bloodstream or secreted after being breathed in? Ultimately, I want to know, do PCBs get from the windows, from the walls, to the brain and cause adverse cognitive function? To get at this question, I utilize a rat model to mimic possible PCB exposures in our school-age children. My ongoing work has already exposed animals to different concentrations of airborne PCBs for 4 hours in a nose-only breathing system. I have yet to test their ability to complete different behavioral tasks, measuring different domains of brain function. And I also plan to measure different brain concentrations of PCBs using methods from analytical chemistry. By studying how PCBs affect the learning and brain potential of our school-age children, we can partner with schools to help minimize sources indoors while minimizing exposure to PCBs, while maximizing the health and safety of our students in this generation and the ones to come. And if you're like me and want to know whether PCBs are getting from the window, from the wall in schools to the brain of our school-age children, you'll have to stay tuned for my future research results.